So welcome everyone to Cybersecurity Management. This is webinar 3. We'll be covering the idea of implementing security controls and security technology into an organization, the types of security controls that we need to think about, and also how to deploy that and initiate a program, a long-running program, to make sure we get the right security controls into the organization. It's no good, oh, excuse me. My apologies, something caught in my throat. And before we do that, so I was just about to say, it's no good putting security controls into an organization that don't actually address risk. And that is, I guess, one of the major roles of the security professional's job, or the cybersecurity manager's job, is to make sure that the right controls go into the organization, and the organization is not spending money needlessly. It may sound like, well, shouldn't we have controls anyway, and it's no harm in putting in extra controls. And I would beg to differ that putting in controls and spending money on security initiatives that don't have a tangible benefit will reduce the trust that the organization has in the security practice. So I think it's really important, this part, to put the right controls in and to make it very clear that those controls are working. And we'll talk more about metrics a little bit in the next webinar, but it's very good to get tangible evidence that you're making a difference. And that's difficult to do in the security industry, difficult to do in any organization, because security is quite, I would say, it's not hard and fast. It's not clearly measurable. It's quite nebulous and intangible at times, whether you're making a difference. But before I do that, I wouldn't mind just going through the final slide of last week. I'll just drop down to it. So we had, there we go. Now, I skipped over registers last week, but I want to cover that off quickly. The idea of identifying risks through compliance activities, through reviewing projects because they're not aligning with requirements, and then having the threat scenario ready there to educate the person who's putting in, or educate the project team who are putting in an initiative, is that we get an idea of risks. We get an idea of gaps that cause risks to the organization. And whether those risks are realized or not, the organization needs to know about it. And the only way to really communicate those risks is by putting them into something formal and putting them into something that can be later reviewed. And that's the whole idea about risk registers, exemption registers, third-party registers, and asset registers. Now, asset registers is a big topic, in IT and in networking, a CMDB, things like that. But I want to look at it from a different perspective. But let's talk about risk registers and exemption registers first. A risk register really should be a catch-all for those risks that you identify as you're going about your role as the cybersecurity manager, and also for your cybersecurity practitioners to put those risks into the organizational risk register. And the idea is you capture those risks and you allow them to educate what you put in for your security program the next year. Now, you may say, what's the difference between risk and exemption? Surely the risk register is filled with exemptions. I would say that an exemption register is more a lack of compliance and individual instances of lack of compliance. So you might have two projects that are putting in servers, and both of those projects don't have strong passwords in their servers. Now, an exemption, that means you've provided two exemptions, but you've essentially got one risk. You've got two exemptions that are specific to projects, so project 1, project 2, both have an exemption, but the risk is that you have weak passwords in servers, and then in the risk register, you might take a note of what those servers are, but it's a single risk, whereas an exemption is multiple items. So it's a a one-to-many relationship. You might have one risk, but lots of exemptions. So it's important to keep a track of the exemptions that projects or initiatives or third parties require and ask for, but they should all feed into a risk, right? So in some organizations, FTP and Telnet are mainstays and rife and are rife and are used regularly. That would be a risk. An exemption would be someone putting in a new system that uses FTP and Telnet, and that would be an exemption, and you put that exemption referenced in the risk as well, so you could go back and find it. Excuse me. The third-party register is really important as well. You want to be able to have a good idea of the security posture of the third parties you're dealing with. We found this out with Target. It's been widely, publicized that Fazio, the AV, the air conditioning provider, had network access into the Target network and was the people who got those credentials that could then move about quite freely. That is a significant issue. But the idea there is that you would have a third-party register of where those guys did not line up with the security posture you would expect them to do. And that's good to have, and you would continue to apply pressure to the third party to say, hey, you may not be using kind of standard antivirus. Why don't you do that? You're not doing training for your staff. Why don't you do more of that? But then it's also good to have third-party registers so you've got contacts in the case of something going wrong. If you have a third-party register, it also should include their incident response people or their security people or IT managers so that you can call them up straight away. Say, look, we've got this account. It's logging in. It's kind of out of business hours and not really when you usually log in. Is this you? Is this what you're doing? And maybe that's not right. So that's why we have third-party registers. We need to keep an idea. It's not that hard. It may sound onerous for those organizations that are dealing with so many third parties, but I've worked in some organizations that almost do everything through third parties, and this was very valuable. The more third parties you use, the more valuable this becomes. An asset register traditionally talks about all the systems and network elements they have in the environment, and that's good. But from a security perspective, we want to think about it in a few different levels. We want to think about the applications, the information repositories in that application, and the system that sits on that the application repository sits on, the information repository sits on. And then also the business and system owners of those assets, right? So let's take a standard customer service or customer relationship management system, a CRM. We have probably a number of servers where this application is sitting on. So we have one application, and we probably have a number of information repositories, and we have a number of systems. For the information security professional or the cybersecurity manager who is having modifications made to this stack of systems, it's important for them to know if a server is modified as part of another project, what information repositories and applications sit on that server, because then that will inform you of what the asset is that is about to be modified, and you can make a valid risk judgment. If someone just walks up to you and say, hey, look, we're just rebuilding this server, we're not adding it to the central authentication, it's just going to sit on its own for a while, is that okay? And they give you a server name. How on earth are you supposed to make a risk judgment with that without understanding the purpose, the business purpose that server kind of fits into with the application information repository? So that's the idea with the asset register. It's not very well done in organizations, but I encourage you, as you are a cybersecurity manager in an organization or a security professional, I encourage you to start building up a map of the applications, the information repositories, and those who own the systems and information from a business perspective and technical perspective. Very important to do. So that's kind of what I wanted to cover, that we ran out of time with last week. We'll now jump into visionaries and leaders. There we go. All right. So the idea with visionaries and leaders is that there are those in the organization who are technical warriors. They go down, they fight in the trenches, they battle the bad guys, they protect the organization assets reactively, right? As a response to something going on, and they're searching for someone doing something wrong. Then we have the critics who are reviewing the security status across the organization in different forms, be it at the project level, at the organization level, for third parties, for compliance. They're looking for the gaps to fill. Now, the visionaries are more proactive. They're more forward thinking. So we have this set where, and I'll move into the next slide. We have this set where we've got the warriors, the critics, and the visionaries, where it is becoming more proactive and strategic as you move to the right-hand side of the slide, and is becoming more reactive and tactical as you're on the left-hand side of the slide. So that's how it kind of fits together. Now, if you think about a project review, it kind of goes the other way. You would have the visionary or the architect or the strategist giving requirements to the project. You would then have the critic reviewing the design of the document of the project, the design documents and things like that. And then you would have the warriors doing the testing, the security testing, rolling the sleeves up and getting the hands dirty and actually doing the testing. So they all fit. It kind of fits into this paradigm of the full end-to-end security practice of how we operate in an organization. So that's kind of a bit of an insight into a deeper way that the team works in these pillars. The visionaries really need to think about what's happening in the future, right? They need to think about the problems of the existing organization and how they will resolve those at a higher level. And that's really the skill of the visionary, is to lead the organization down a path that will reduce the risk overall. And I think it's a very rewarding role to play. So what happens with this enterprise security architecture? And that's really what we're talking about. We're talking about that bigger picture, the scope of the entire organization, the scope of all the assets, the scope of all the partner connectivity and the ways that the information moves around the organization. We look at big repositories and macro kind of zones and different systems that interrelate and middleware. And the thought of the visionary is to understand how that all interrelates and to put in the effective and efficient controls to ensure that we address risks. And the whole idea is that the visionary and the leader doesn't just know the technical aspects of the technology that they're dealing with, but also understands the business and organizational needs. What does the business want to achieve? Does the business want to stop growing and just throw in as much security equipment as possible, hunker down and be really protective of its organization? Or does it want to grow and push out assets and bring the customer in? And so you need some sort of flexible, intuitive and well thought out controls that will address risk and nothing more. Like, what does the organization want? What is the character, the business goals of the organization? So that's kind of the really important part for the security architect and the visionary to really understand. And it really is about that. It's looking forward, it's trying to achieve those goals for the organization, and it's trying to address risks at a higher level, right? So this is really important. So if you're sitting there as a security warrior and you are waiting for spam and phishing to hit the the network, so you can put in extra control and resolve it and all that sort of stuff. You might put in a filter to stop certain subject items getting in there, right? And that's really the tactical approach, the low-level piecemeal approach. The visionary, the cybersecurity visionary, is intent on addressing risks as classes, as higher level issues, right? So they're not interested in just fixing one or two spam or phishing emails and blocking them as they go. What they want to do is bring it up a level and block a whole class of phishing or a whole class of spam and change the paradigm so that it fixes a whole class of issues rather than at the lower level. So they might instead implement a whole new control, not just blocking on a subject, a whole new control, like maybe implementing a new RBL or doing some gray listing or no listing or something, kind of fancy for the spam to drop off a whole class of attacks, right? So that's the idea. It's not just about the low level. We're not just putting in piecemeal things. We're doing things at a higher level, addressing risk at a high level. Now ask yourself, what we may be attacked by this type of attack now. How can we make sure we're not attacked by this type of attack in the future? And that's the question that's always been asked. So that's it, the technical knowledge and business alignment. I think we covered that pretty well. But that's the idea. The visionary and leader is supposed to lead the organization down that path of new controls and systems to protect the organization. Now, what are the principles that go with this? This is not exhaustive, but it's a good collection of things to think about as you are putting a security architecture in. You want to think about defense in depth. This is pretty common cybersecurity terminology. You don't just want to have a thin layer of control. When one of the things I like to and am very keen on doing in many organizations I've been a part of is to get rid of administrative interfaces that are exposed, or to get rid of applications that only have one factor of authentication, things like that are exposed on the internet, right? So we don't want to, unless absolutely necessary, have a single username and password for systems that are exposed on the internet. Inevitably, there is going to be some weak usernames and passwords, or the passwords are going to be exposed somehow, and unauthorized access will be granted. So that is an example of a single layer of defense. What you want is multiple layer of defense. So this would be like having an internal system now put back into the organization, and to get to it, you have to have two-factor authentication and then get to the system. And that is a defense in-depth strategy. Okay, so it just means multiple layers. It's important to keep things simple. There's nothing like complexity that will unwind a security control very quickly. And we see this with web apps all the time. We have elegant authentication systems that are quite complex, and then it's shown that they have a simple bypass because the designer didn't think of that particular condition. And it's just a matter of not being able to think of all the cases because it's so complex. So simplicity is very important. A simple control is one that is easier to use, and then that becomes the path of least resistance. So there's this big dichotomy in information security and cybersecurity that says the more security you have, the less usability you have. And while I think to some degree that's true, I think there is a sweet spot in their crossover from usability and security that gives you a security control that is the path of least resistance. And to me, that is the most important security control. A security control that adds complexity in terms of the user experience will inevitably be bypassed because it's just easier to do something else. So we think about NAC, maybe a network access control. You plug into the network and then it prompts you for 2 passwords or something like that, and then you're away to the network. what might happen is that people are a bit annoyed with that, so they just tether with their mobile phone and get access to the internet that way. And then they're outside of the corporation and they're not filtered for web and SMTP, all that sort of stuff. So you'll find the path of least resistance reducing your security if your security controls are too hard to use. You'll also get rejection from the business. So we need simple and easy security controls. We also want automation. So a security control that requires multiple levels of authorization to be implemented is inevitably going to cause a problem. Things that require a lot of administrative effort will always drive away from themselves, will drive the business away from those controls. So automation is good. Low administrative effort is excellent. Only expose what is necessary. This is the the least privilege concept, very commonly known, and is really important for all of your systems. You look at your review and you think what is necessary to expose. Now, I'm not always a fan of least privilege. I think it's important for people to have control over their computers to some degree. I've seen systems or environments, corporate environments, where you can't kind of even change how the taskbar looks, and that's because of security reasons. I don't know what threat that is addressing. I don't know what risk we're addressing with that. Maybe we're just reducing IT support costs, but we're not reducing a security risk. We're not addressing a threat directly. So I don't like those things being done in the name of security. Every security control that we put in place must have a plausible threat scenario against it. Otherwise, we're not doing our jobs. So we only expose what is necessary, and we take that principle of least privilege only to where it's addressing a threat. Now, obviously, we need to align the enterprise security architecture with strategic goals and compliance requirements. We don't just have to serve the business. We also serve the business by getting compliance, but we always have to think about both angles. We're kind of serving two gods. We're serving a strategic goal, and we're serving compliance. Now, if we can achieve the strategic goals while hand in hand achieving compliance requirements, that is the best outcome. And then we think about the exposure of different assets, right? So if you're thinking about zones and architecture, you've got to think about two main things. You've got to think about which network is exposed to untrusted systems and how is that network exposed, and which network has high business value in it. So obviously you don't want to put your high business value in a highly exposed network, and you want to group those environments together, right? So things that are exposed are grouped together, and things that are business value are grouped together, because it makes it easier to apply controls to those environments. If you have a high business value environment, you can put lots of controls around it without restricting those environments that need to be exposed, right? So we're thinking about a network security architecture now with those systems that are exposed should not be sitting next to those systems that don't need to be exposed and have high business value. They're the two main considerations of network security architecture. All right. Now, cybersecurity standards. I'm just going to rifle through these. The reason why I bring this up, we did touch on them in the earlier live session, the first one, the webinar around standards, policies and standards. But it's important for the visionary, the cybersecurity visionary, to think about what is in the standards and to manipulate the standards so that they drive a business goal. Now, you think that's kind of strange. How can we get the security standards to have good items in there, or the appropriate items in there, to drive the organization to where it needs to be? And that's precisely what's going to happen, because if you put too much in the cybersecurity standards and you make it too restrictive, the business is going to find it hard to get to where it needs to be. But if you have the right amount of control and you pare it back to the right amount of control for the business to meet its objectives. It's not restricted, but you're still addressing risks, and that's really important. The other thing is the security standards should guide the architecture, because as the security standards identify areas of the organization that aren't quite up to scratch, you can use your security architecture, your security controls, and your security um, um, initiatives to bridge those gaps in that aren't currently satisfied. All right, so some of those security standards are network security. You want to define really how new environments are created with zones, how the web infrastructure will look, the risky protocols that are in use in the organization, what's allowed to be used and what's not allowed to be used. Maybe that will drive a new file transfer mechanism, something like that. Cybersecurity, the system security. So what do you need to harden at a basic level? We're not talking about individual or specific technologies here. Do we need antivirus? Do we need central logging? We have maybe an encryption standard as well, where we endorse certain cryptographic and hash algorithms. And the reason for that is, and make sure we get our HTTPS right, our TLS and SSL. The reason for that is that the organization will check boxes and ask for securities advice on some of these things, and to quickly come back with, you shouldn't use MD5, you should use SHA-2, is a great way to just quickly provide them advice and they can move in that direction. We then have destruction and decommission standard. We'll make sure that when we are finished with the system, we kill it properly so that the data cannot be recovered. And also a secure development standard, which articulates how web developers or software developers and software developers are meant to behave when developing software. We also need a security standard for access and account control, which decides how strong your passwords need to be, how often they are needed to be reset, how to get a new account created, how to delete an account, and how to review accounts all the time. Now, you may think, well, that's just all very basic and very boring for architecture, where we're throwing in these U-boot IPSs and firewalls and spending lots of money. But all of this stuff, as you're putting them in, the standards that you apply to the whole organization must also apply to your security initiatives. Sometimes security people will be critics for the rest of the organization, but allow their own projects to bypass that that checkpoint. Now that's that's quite controversial, but it can happen. And it does happen. So it's important to remember that as well. All right, so we've talked about the principles of enterprise security architecture. We've talked about what the visionary needs to do to align with the business, and having standards there that kind of guide the new solutions and initiatives in the organization. Now we're talking about preventative controls, right? We're talking about how these controls work. And the idea is that they block the incident before they occur. And that's like having locks and doors and locks on your windows and stuff like that. You're basically stopping and preventing a crime, like someone breaking in, before they're able to. This is where the majority of the resources and effort goes when implementing security equipment. We're often thinking about how to stop it before it actually occurs, and how to prevent an incident rather than detect. Okay, so this is where traditionally all of it is, and I guess it makes sense. It's less administratively heavy, but you can't neglect the the detective controls, and we'll cover that a little bit later. But yeah, this is where most of our time and effort goes into. Now, it's arguably getting less effective to prevent cybersecurity incidents. They're still occurring. I kind of agree with this partially. I mean, I think it's true. It's getting harder to prevent them. There are more ways into the organization than ever, like we've already discussed. But it's still very, very important. There is no alternative to these preventative controls in a lot of cases. You can detect, and that's good. You'll find an incident earlier and get to resolve it quicker. But generally, the preventative controls are getting less effective. Now, there's 2.5 main categories for preventative controls, and I'll run through them. There's host-based, network-based, and cloud-based. And I call cloud-based half a category because it's basically a mix of host and network, but it's just run by someone else partially. And I'll go through the levels of cloud-based controls a little bit in later in this live session. Now, network perimeter controls, we have 3 kind of big ones that I'm going to call out. This is not exhaustive. There's so many different controls. People are thinking up controls. There's hybrid controls. There's all sorts of things. So let's just run through these ones. There's firewalls, network-based IPS and IDS, and VPN systems. Now, the firewalls, obviously your perimeter. They're like your fence, your gate. They also can act as an inner choke point between zones, which is really a good idea as well. And then you kind of have also this option of having unified threat management, or UTM, on these firewalls as well. So not only are they restricting traffic, but they're also looking for bad stuff as well. And they can also do DLP and web filtering and IDS, IPS, and whatever. There is always capacity issues with firewalls. It's really the expensive ones have 10 gig interfaces and have lots of throughput. The more throughput you get, the more processing you need, especially with the UTM ones. They actually need a whole lot of grunt to do what you want them to do. So if you have things that are directly on the internet and need to be exposed to the public, sometimes the firewall will be the smallest choke point and will be your problem if you have a flood of traffic or a denial of service attack. Some examples of firewalls: Cisco ASAs, checkpoints, FortiGate, Fortinet, and IP tables. I'm always going to give you an open source option in these examples. I'm not endorsing any particular products. I do have my own favorites, which I'll take particular questions about if you like. But in general, you can use any of these technologies and the mainstream technologies to achieve, the basic 80% of control that you need in that particular area. I definitely don't go for, not always go for top of the line products. I have done in the past, but I do like to take a step back and go for the practical, pragmatic approach and look at lower cost options as well. Often security has the benefit of having a bigger budget, or sometimes has a bigger budget for implementing controls. And a lot of the times there is a temptation to just purchase the highest top right rated technology in the Gartner Magic Quadrant just because it's sitting in that position. What you need to do is to work out your business requirements and then work out your security requirements from a functional perspective and determine if you actually need that. And that is the best way to serve the business, because maybe you're spending money that you don't need to spend. All right, network-based IPS, IDS, so intrusion prevention system, intrusion detection system, or IDP, intrusion detection and prevention. Usually signature and behavior-based, looking at network-based attacks, what's running over the wire. Most effective when tuned, okay, so you can really knuckle it down and do a good amount of review of your own traffic and then really stop anything else. That can happen and is a good thing to happen, and that will make it quite restrictive. It can cause problems because then it actually needs a fair bit of resources to ensure that it doesn't stop anything legitimate, and that's important too. Common examples are SourceFire, Cisco, Tipping Point from HP, FortiGate also does an IPS, and then there's the open source Snort as well, which is actually what SourceFire is built on. The VPN, the two-factor authentication, is really important in everyone's mind these days. We all know that there's been so many password breaches, that there's so many passwords out there to try. I've got some word lists that will that are. I saw some research to say that there's a word list out there that will break 20% of the wireless networks. So you've got to think about that. That's a difficult thing to swallow when you're choosing a password. You think, well, I really do need to make it unique, but because the passwords are so fallible, we have to also think about two-factor authentication. It really is robust. We know that if someone's got a token, then there is a good chance, unless they are, have been very exotically exposed or compromised, that they are who they say they are. So the token is a good measure of authentication and a good measure of who's actually on the line. It's also important for staff, not only staff but also third parties, as we've seen in the Target incident. It's also a good idea to have multiple options for VPN, not only tokens, but also something over the smartphone or even an SMS token, something like that. Obviously, with different levels of security depending on the technology, but it's really important as well. Then some obvious options are RSA and Google Authenticator. There's a lot of other options out there as well, safe word, all sorts of 2FA options. Now, we'll do this slide and then we'll do some questions. Now, application perimeter control. So we had the network perimeter control. This is stuff looking at the wire and stopping traffic that looks suspicious or outside of the rule set. We also have applications that are on our environment that need to be exposed. Web application firewall is a device that sits in front of your public-facing web infrastructure, or maybe even your internal-facing web infrastructure if you are required to protect it there. That gives you this protection from SQL and command injection, and it really should be in front of all rich web applications to some degree. If you've got forms and posts and GET requests where you have rich responses or dynamic responses to the users for your web application, it can be very complex and difficult to secure it. And that's what web application firewalls do. They some of them can be tuned and analyze your web traffic, and then will look for anomalies and block those anomalies. Web applications are really important to secure. It sounds very obvious, but if you are putting your customer database or your internal staff database right close to the public internet, and you are protecting it with simple forms, it's just behind a web server in a database, then you have to be pretty sure that you're doing the right thing by the web application to ensure people can't get through it to the database. It is really bringing your crown jewels close to the cliff. Right, so that's why the web application firewalls came into being. There's so many web application exploits and so many vulnerabilities and so many breaches that these are a necessity. Some examples are in Imperva and F5. I think they're the two top right-hand corner ones. Then there's also ones, the Apache built-in mod security and also Naxi for Nginx. Really good open source alternatives and often good enough for the job, but if you need the fancy GUI, then maybe the commercial versions. Anti-spam is boring but very much necessary. If you think about email and you think about how many breaches begun with an email, the levels would be very high. The way that the bad guys coerce staff members into doing something is usually first with an alarming email. Your password's about to expire. Please send it to us, or else you won't get access anymore. Or here's a parcel that you need to go and retrieve. Or you've got a tax return. You click here and we'll let you open it. Or here's a document from the scanner. All of these, or here's a link that someone's sharing with you to go and grab this PDF. All of these techniques are available because email addresses are accessible from the internet to the public. So it's almost like every individual person in your organization has their own little private area where people from all around the world can communicate with them, right? And they are susceptible. All you need to do is find out that email address. It's not secret. Email addresses are often splashed about because they're not considered secret. That those spammers, and once you get on the spam list and the phishing emails, those guys will first try the email. It's an easy way to do it, and the only other way to really contact someone individually who has access to internal systems is over the phone, and it's nowhere near as effective as running something on their computer. So anti-spam devices, although not very exciting, play a crucial part in ensuring the security of your organization. It's the first line of defense. Like you look at the three major ways that organizations are breached. One's through the website, the other's through emails, through phishing, and the third one's through wireless networks. Now, if you have those three areas sewn up pretty well and you invest in those areas, then you're dealing with a lot of the risk that exists. All right. That was a soapbox moment. I'll move on. The couple of options there: Iron Ports from Cisco and Spam Assassin or Spam D from the open source options. There is a lot of open source options for anti-spam, although it does require some specialist knowledge to get a really good system up and running. There's also web filtering. Now, this is not the same as web application firewall. Web application firewall is protecting your own websites from the public internet. Web filtering is protecting your staff from browsing bad things on the public internet. So it's that outbound filtering, protects from phishing and virus sites, and that's another step in that infection chain. So when they get that email that is just a URL that says go visit this site and download this PDF, excuse me, then the web filtering has the possibility of knowing about that phishing site and stop it and blocking it. Some options there: FortiGuard, WebSense, or Dan's Guardian. Dan's Guardian's the free one. Does it on word analysis and things like that, which is pretty cool. There's also sandboxing. This is more sophisticated. It's what they're systems that sit in your web and like your web browsing and SMTP traffic, so your email and web browsing traffic. So all of the interactions that your staff have with the outside world go through these systems, and they capture files and executables and attachments as they come through, and they run them up in virtual machines to see what will happen, and then analyze them on the fly and make a decision if they're malicious or not. And these are really like those zero-day protection, the APT protection, advanced persistent threat. A couple of options: FireEye. I know Fortinet's got one as well. There is called FortiSandbox. There is a whole bunch of them. Cuckoo is a one that is an open source one as well, a good option. Then there's DLP. There's all sorts of data leak protection systems out there, but really what they allow you to do is put regexes and to put document signatures and certain values into the systems to monitor for sensitive data leaving the network. It's a tough job. There's lots of things going in and out of the network. Sounds really simple. The biggest problem is getting the business to point its finger at information that it wants to protect and wants to protect for a long period of time, because some things it doesn't want to protect forever. So that's the tricky part there. And I'll say this, that a lot of the tricky part of security technology is making sure you implement it to the business needs. All right, Maggie, we might do a couple of, we're well and truly halfway through. We might do a couple of questions right now if you're to take a break. This is going to be a bit of a long haul through all these controls.
Yep, can you hear me?
Yep, certainly can.
Awesome. Okay, so the first question is how much do you have to account for password fatigue and people not being and people not being able to remember passwords that are an encrypted PIN device is more secure? Do you want me to read that again?
Yeah, yeah, I think I got half of it, but
Yeah.
yeah, please do.
Sorry. How much do you have to account for password fatigue and people not being able to remember their passwords?
Yeah.
And are encrypted PIN devices more secure?
All right. Yeah, sure. Okay. Um, Encrypted PIN devices. I mean, I think what's meant there is tokens and soft tokens and things like that. So, yes, they're more secure because it is very difficult to guess the passwords. The password fatigue is high. Um, I think a lot of people now, I mean, are used to using the same password across multiple systems of different security levels, but I know that I have different passwords for things that I deem quite sensitive and things that aren't very sensitive, right? So I've got different levels of passwords that I use, and if one of those passwords gets lost, like one did in the what was it the Adobe breach actually. So one of my passwords got lost in there. I changed that whole class of passwords across where I was using that, and that's a bit of a pain because I don't know really did I get them all. I just did it to my memory. I might have missed something, but the important thing is there that having too many passwords does make people forget them, and password managers aren't infallible either. And we see now that passwords are cached in Chrome quite easily and follow you around to whichever computer you're using when you log into it, which means it's being stored somewhere else in reversible encryption. And you're just trusting that those things are being done well as well. So it's a difficult thing with passwords. It's a really convenient way to provide access. There's so many systems that aren't all hooked up that everyone has all these passwords. So going to something else is much better. So encrypted PIN devices such as such as tokens and things like that, like timing devices, very much a better way to go. But I say coupling it with a password or coupling it with a PIN code is also a good thing as well. Just gives that extra factor. Yeah, I think I answered that. That's all right.
Yep.
Yep.
Um, could you please provide a few examples of issues to be considered with regards to destruction and decommission? Hello?
Yeah, sorry, can you read that one again? I was
Yep,
got half
sorry.
what I was writing
I
down.
thought my sound had dropped. Could you please provide some examples of issues that might be encountered with regards to
Yeah,
destruction and decommission?
yeah. Okay, first issue is that sometimes it's hard to get the equipment to adequately destroy hard drives and things like that, right? So that's the first issue. Um, I I like the idea of shredding hard drives. It's much better than drilling a hole through it or whatever. That's good too. I know some people take hard drives out onto a farm and use it for shooting practice and whatever. So there's all sorts of ways that people do it. The second problem is that if you don't do it, and the threat scenarios that arise if you don't do it and you sell that hardware to a recycler, is that inevitably that hardware gets reused somewhere and gets falls into the hands of someone who's not supposed to have that data. So to be safe, and if you want to actually sell the equipment into a recycler, then you should be doing a three-phase wipe or something like that for your data destruction, or physically destroy the drive or the equipment. I think that's it. Maggie, or shall we take one more?
Yeah. Other than penetration testing, what are the other effective methods to test the implementation and robustness of various controls in a corporate environment?
Other than penetration testing. So there's audit as well, I guess. So if you look at the configuration of the device or the control and you look at how it is set up, then you can go from the make an assumption from the administrative interface that it is doing the job it's supposed to do. You can also audit the logs that are coming from it to see if it's actually stopping things or if things are getting through somehow. You can also compare it against different technologies. I know some people now, when they're going to product selection, will get two of the same product, plug them both into a mirror port and see how they both work, some things like that. But really, the only way to know properly if it's doing its job is to test it thoroughly. And even then, not every test is perfect. So the penetration testing and the auditing and reviewing all coupled together is probably the best bet of ensuring that you have a good control. Okay, I think that's cool. Shall we continue on, Maggie? Is that all right?
Yep, sounds great.
Okay, great. All right, now on to the next. All right, access controls. This is where we are ensuring that people only have access to what they need to have access to, both from a public and customer perspective and also from an internal perspective. Basic systems like file system permissions, where you have users sharing files with each other and making sure that only those people who need to access files for business purposes get access to them. This means group shares, private shares, things like that are not readable by everyone. They're only accessible by those who need access. Again, a least privilege idea. We also then have authorization within applications. So you may authenticate into an application so it knows who you are, but then once you're in there, you should only be authorized to see what you need to see for the business purpose. And that can be very complex. Each application is different, and also bespoke applications may not even have any authorization, may be retrofitted and not be quite right. So that's something else to remember with these security controls. And also when you're putting your own security controls in, you want to make sure that you can have levels of access. So you may want some people to have admin, you may want some people to only have auditor or read access so they can only do certain things. We then have account controls, which are really about resetting passwords, how how accounts are actually created, the naming convention, all of those things that make it a neat environment to have accounts in, so that people know what they're dealing with, and to ensure that accounts don't last beyond a business need, right? So you only should have accounts to systems you're authorized to have access to, and if you leave the organization, you're not authorized to have access to any systems anymore, because you're not trusted, you're not under contract anymore. It's not likely that the honest citizen will do anything wrong, but you can also put it down to curiosity as well. You get home after leaving your job and with a week off to go into the next job, you wonder, I wonder if my VPN account still works. I wonder if I can still get in and get access to the systems. So we need good account controls. Password control is really important. We talked about these in the standards, and the standards should really educate and drive these controls to have complexity, to have expiry, to have a reset process, to have encryption on the passwords as they're stored, with salting if possible, so that you don't have the same hash for the same password and you aren't susceptible to rainbow tables as well. So there's all these controls that you need to have for access for accounts and passwords. And then also there's this kind of maturing technology called Privileged User Access Management, or PUAM, where you set up a host to act like a kind of a landing spot for all of the privileged system users and network users to come into the environment and be tracked and logged with all of their access. This allows you to also have role-based access control and treat the fleet of servers like an application with different privileges. So you can say that you want to give the Windows users access to just the Windows systems, or you want to give the Unix users or Unix sysadmins only access to the Unix servers. And you can use PUAM or Privileged User Access Management to do that. Secondarily, it's a good way to keep track of all of the root passwords and administrative passwords and not have to expose them to anyone, and retrofit access controls. Very clever stuff. There's some really good options out there. CyberArk's one of them, and I'm trying to think of the other one. There's another quite expensive one that I can't remember the name of. You can also do this with some fancy SSH proxying as well, just for the Unix and Linux systems. We then move on to system controls. So these are servers and workstations that and network devices that are in your organization. These are the systems that people have the most interaction with. We need to have a good patching infrastructure. This means that you have a way for each server and workstation to go out and fetch patches for itself, and for you to be able to push patches and updates to these systems. It should be automated. That is the nirvana, in that you just get patches rolled out and tests performed without you having to worry about it. You might have a test environment where this happens, and if it all goes well, it naturally goes out to the production environment. That is absolute nirvana and very difficult to do, but is good to have. And then you might have a different requirement for exposed and not exposed systems. So you might have a patching regime that happens automatically every week for systems that are exposed to the internet, and maybe every 3 or 4 months for those systems that are sitting internally. Obviously, the risk posed to each of those is different, also depending on the asset they're protecting. We then look at server hardening. We look at build standards. So you have Unix and Linux systems that are configured, particularly things like Chef and Puppet are good for this as well. We then make sure we're only running the services we need to run. There's countless times when the additional services are vulnerable and are exploited to get access to the server. We also then can put something like HIPS on, or rootkit detection systems on the system, to ensure that they're not compromised in any way, which is good to have as well. We then look at other hardening, workstation hardening, so away from server hardening now to the desktops and laptops. Again, build standards. We have antivirus because mostly they're Windows. Also whitelisting applications, so that you only have those applications that need to be run. A really clever way of doing this is whitelisting applications only to run from the program files, so they can't be run from the desktop and from the temp directories, and that does stop people running CryptoLocker when that downloads to their temp directory. Also having a personal firewall, because usually these days a laptop doesn't just reside on the corporate network. It goes home to a home network, which is totally untrusted and has the 13-year-old son next door trying to hack into it. So in the room next door. So think about that as well. And HIPS also works for workstations and laptops, so that you can do heuristics and also look for indicators that the workstation is compromised. There's also this term IOC, which is indicators of compromise. These days, there is some heavy software going into workstations for endpoint. It's very in vogue at the moment to put software that looks at every application that is executed, gets a MD5 hash of it, and sends it up to a central server to identify whether it's a malicious program or not, right? So this and is indicator of compromise. So these systems are pretty much building a big data store of everything that happens on workstations to combat the APT issue. Very interesting area. Now, data controls, we not only want to protect data while it's there in storage, but also when it's passing over the network. We do this by encryption and hashing obviously for passwords and things like that. Encryption needs to be of adequate strength so it's not feasible to break it. And the biggest problem with encryption is making sure the keys are handled correctly, as Dell has recently found out. If you have a read of the news with their root certificate private keys distributed with their workstations, very interesting stuff. That is a really important thing. Encryption can be applied, but the keys are paramount. I was going to say the keys are key, but that wouldn't work. Now, data retention, you've got to reduce the asset. Now, we're not just talking about wiping data, which is covered in the next point, but we're talking about this principle of making sure you don't create an asset where there doesn't need to be one, right? So a good example is taking newsletter information for your customers, right? So say you want to provide an opportunity for them to fill in a form so you can send them a newsletter every week about what you're selling and what developments there are in the industry. Now, if you put in that form, what's your name, your first name, last name, street address, and your email address, and they're only signing up for an email thing, then you don't really need the first name, last name. Maybe you do for greetings. So maybe you just need their first name. You don't need their address. But if you start collecting all of that information and place it in a database behind a web server, you're actually starting to accumulate a whole lot of personally identifiable information that doesn't need to be collected for business purpose. And often we take the opportunity to collect data just because we can, because it might be useful in the future. Now, I challenge all of you as being cybersecurity managers or budding security professionals to challenge the business when they say, this is the data we need. You say, do you need all of this data or only a subset of it to perform your business? And you say, if you find you do need it, then that's absolutely fine for the business. You give me a good business justification. And don't challenge the business justification. If they have said they have a business justification and they describe it to you, then you have to take their word for it. They're the experts in the business. But just simply challenging them that they may not need to keep that data and accumulate that data, and it's not just about the quality of the data, like which fields you have, but also about the length of storing the data, then you are reducing that asset. You give them the opportunity to reduce that asset. So that's really good. That's what we want to do. We want less assets to protect because that means we have less risk. And then we have data removal. We talked about 3-pass swipe and disk destruction as well on the data controls. Now, cloud controls. Now, these are really, this diagram I came up with because I was dealing with quite a few different cloud environments where they were just, we had to apply different levels of control. So with security as a service, we really only had to think about 3 things. Third-party security posture, so we give them a checklist, are you doing the good things with passwords? Are you developing right? All that sort of stuff. Are you using good encryption standards? So that's the third-party security posture. What are you doing? We then talked about, are you encrypting our data, or are we encrypting the data within the software as a service system? And are we managing our own accounts? Because obviously, while we've got software as a service, we're not responsible for a lot, but we are responsible for who we give access to access that application. So they're the main areas. How is the security posture of the third party that is hosting the SaaS? Are we encrypting the data that's going into the SaaS so not even they can get to it? And are we managing accounts? Now, when we move to platform as a service, we're really talking about servers and an application level, but we build the application on top of the application platform. So then we have to think about application security, like how we develop the application to function, development security, so making sure we have secure code, and privileged user access, because now we have a number of developers who have a higher level of access than normal users who would only be available in the SaaS, right? So we have to think of privileged user access as well. But we also, for PAS, have to think about account management, encryption of data, and posture as well. So we have this kind of growing set of controls from SaaS to PaaS to infrastructure as a service. Now, for infrastructure as a service, we basically have all the controls of a traditional data center hosted by our own company. We have network zoning and server security to really think about our hardening. We also have privileged user access, development security, application security, account management, encryption, and third-party security posture. So the infrastructure as a service has more onus on the user of the infrastructure to have security controls in it. So this is the sort of things that you have growing responsibility between SaaS, PaaS, and infrastructure as a service for the security controls in the cloud environment. So that's just something to think about as you make use of these different cloud systems. They are just all systems hosted on other people's other people's servers that are connected to the internet, right? There's nothing fancy about the cloud. It's just servers out there hosting different applications and allowing you to host your own servers within their infrastructure. That's all it is. And it means the more responsibility you have for that platform, the more you need to think about the security controls, right? And the more responsibility the third party has for that platform, the more scrutiny you need to put on them to ensure they're doing the right thing. So that's the big picture with cloud controls from an architecture perspective. We need these controls. We have these requirements. How do we make it all fit together? I hope that's clear. Now, detective controls. We've talked about preventative controls. All of these controls we've been talking about allow us to block things happening, allow us to stop incidents from occurring, and to have a better chance of staying free from breach. Now, all of these preventative controls can be hooked up to central logging to become detective controls, and that's how it should work. As the environment changes and moves, the preventative controls are not static. You need to have some sort of feedback loop so you can test their effectiveness and modify them as the environment changes, new networks are added, new systems are added, those things. And that's all about having that loop with logging and detective controls as well, because maybe some things are getting through and you need to tighten up the preventative controls. So they go very much hand in hand. And the way you get that feedback loop is also to perform those test attacks. Make sure you do those so that everyone is clear as to how effective the detective controls are. You don't want there to be, there's two bad things that occur with security controls. One is everyone blames the security control for an outage because it's only recently been deployed or something like that, and it hasn't been the outage. So you've got to dispel those concepts quickly. If it's not true, if it's true, let it be, and fix up your security control. But the second thing is that there's a thought that security control doesn't work at all. That and undermining the confidence that the business has in the security control that you've put in place is not a good thing. So let's make sure it's effective, but not so effective it actually stops the business operating. In detective controls, one of the major things we have is logging and monitoring. All of these systems need to come back to a central place. There's far too many controls and points of interaction with people now to look at all these things individually. We need to centralize logs. We need to make sure we have the information at hand. That means we need to tune those systems as well. We only want the security events and those events that are related. More events will just create more noise and be harder to search through. Obviously, our Greylog system is good at searching unstructured data, but even it has its limitations when you are throwing gigabytes of data out a day. Obviously, you need a fair bit of computing power. It can do it, but you just need the setup to do it. We've been, and I'll take a pause here to say that I've been very impressed with everyone's efforts with the week 2 exercise. The amount of data that we've been getting into the IT Masters Greylog server, I've been watching it every day growing. I've been watching the comments particularly thanks to, I want to say Samuel. There's somebody who set it up fairly early and produced a document that they've been sharing with everyone on how to get
That'd
it.
be Samson.
It is
Samson Yu.
Samson? Sam,
Um,
Samson or Sam?
yes, and he's in the webinar right now.
Ah, well done. I want to thank you personally for all of the help you've been providing to everyone. I think everyone's found that well. Everyone's been providing you with their email address and to send your document through, and it's helped a lot of people. So appreciate that. We've got some good instruction for the VirtualBox setup, but everyone pitching in and actually helping out in those exercises is really what it's all about. And I'm hoping that you've all learnt valuable concepts in central logging and failed authentication attempts. And I particularly like those who tested the failed authentication attempts with THC Hydra. So what you've done there is you've taken those central logging feeds, and then you've actually run a password guesser against the feeds, and it's made it so you can test the effectiveness. So you now know, as you do this, this test, what it looks like when someone's trying to hack into the environment. Obviously, it sets off 300 failed authentication attempts within a few minutes. So then you can go into your central logging and monitoring system like Greylog and say, look, I can identify the failed login attempts. If I see more than 50 of these in 2 minutes, then I've got a problem. I need to be alerted about that, and you set up an alert in the stream. And this is the outcome, where you get this actionable event where you can actually go and do something about it and be notified, and you have this underlying database of information that you can then data mine if an issue occurs and you need to investigate it. So yeah, I've been really impressed. Everyone's given it a good go. There's obviously different levels of technical capability in a MOOC such as this. I mean, with so many people involved, I encourage those who have not given it a go yet, even if you don't feel that technically astute, there's plenty of assistance and support, as I've said in the forum, to help you go through it. And it's been a really great exercise, and I hope you've all enjoyed it. And we do, and they're an open source product, so we're not taking any endorsements from those. It's just a really good tool that is filling a niche for those who don't have the $3 or $4 million budget to put something like this in. It's obviously quite simple, but very effective as well. So well done, everyone. I love it. It's very good. All right, so there's this idea of tuning the cybersecurity login monitoring, and we talked about that with the authentication attempts just then. We want those actionable events, but there's this concept that is emerging and maturing called a continuous view of security. So you take in all those feeds from all your security controls and all those security logs from applications and servers and whatever, and you continuously monitor them. And you may have 4 or 5 bar graphs going across the screen that will tell you what is happening at any moment to those systems. And when you see an irregularity or a peak or something, you investigate and you find out what's going on. Very important. The whole idea is to understand what normal looks like in your organization. What is normal practice, and when it changes, what is going on, so you know what you're looking at in the case of an investigation. And also a good idea is automated testing. So you want to make sure that any testing that you do for these central logging and monitoring is automated, and you find things that feed back into your continuous view that will say, right, well, a new vulnerability's popped up, here it is. So you want that scheduled automated testing, not to have someone manually doing it, but also to pop up an alert when there's a critical vulnerability that has been discovered in your environment. Okay, we're going to start running out of time now, so I'll keep going. Now, the cybersecurity program, how do we get all these controls into something the business can actually endorse and move towards? Well, the classic way of doing it is having a yearly program of work that says this is what we're going to do for the year, this is how we're going to schedule it. We want to identify those initiatives and directly address those major risks. So the first thing to understand is what are the risks that are presented to your organization, what are the gaping holes, and how are we going to fill them up. And then we decide on those medium-term initiatives in the 1 year, because you would be surprised how quickly a year goes when you have a full cybersecurity program. Months just tick by. It's very scary. You then gather those indicative costs and you estimate those time frames and the resources that are required to do it. So there's quite a lot of program management and project management in this visionary role, but it's important to be able to have those skills so that you can build the confidence in the business that you actually know what you're doing and will get some of this stuff done. There's this idea also of having a 3-year cybersecurity program, and the whole idea of this is that when you're brainstorming initiatives, you don't just think about this year's initiatives, you think about next year's initiatives and the year after, so that you can prioritize and have a longer term view. And some organizations even give a 5-year view as well. So this allows you to come up with initiatives that are desirable but not urgent, and also to look and target a level of maturity for an organization a few years down the track. Now, how do we find these initiatives? How do we grab all the information we have throughout doing security as a security practice, as the cybersecurity manager? How do we know what initiatives are going to benefit the organization? How do we identify the problems we need to solve? Well, we have to understand the intent of the initiative. We have to understand the burning issue for the organization and how this initiative will actually stop that from being a problem anymore. So we've got to collect statistics and evidence, and we do that in our incident reports. You will find that if you don't write incident reports, you won't collect those things in an easily decipherable way. And that's how you do it. You grab the incident reports and you put them together. You also grab it out of your incident register and your exemption register. Your exemption register, your incident register, and your risk register. Your risk register should have very clearly in it what the level of risk are of the certain risks that you have identified. Is it a high, is it a critical, or is it a medium? And you're targeting those critical risks, targeting the critical risks. And then you will be able to draw down on how the organizations benefit. And how do we do that? Well, we say this particular threat scenario is no longer applicable. Users or malicious outsiders can no longer gain unauthorized access through a guest password, right? That is the business benefit. We have an unauthorized access to an asset, and we have a negative impact. We have the negative impact of unauthorized access, and we have an actor who's the malicious outsider. So that's what we need. We need the asset, the negative impact, and the actor. Those 3 things for threat scenario. I really want to drum it into all of you, the importance of understanding the components of a threat scenario. Now we have to define the project functional requirements, right? Now this is like being a proper IT or network architect. As you're putting together a project, you need functional requirements. Okay, this means the functions, the key things that the system does to function as it needs to satisfy its purpose in the organization, right? And we're not talking about backup, we're not talking about extra CPU or RAM, the non-functional stuff that kind of service the functional requirements or make the functional requirements possible. We're talking about the stuff it must do. So I've got an example here. If you're putting up a project to put in IPS, you might have some of these functional requirements. Now I'll just run through them. The IPS must inspect traffic at key choke points in the environment. Okay, that's pretty obvious, but that's a good requirement to drive through. Maybe if you put up IPS as an initiative, the first question will be asked, where will you put it? Well, we'll put it in key choke points where most of the traffic is running through the environment as the most valuable areas. And that brings other questions as well, but that's a requirement. Must receive signature updates from vendor at least every 12 hours. Whoa, can all vendors do that? Maybe that cuts out half the vendors. Must defend against zero-day application vulnerabilities within 24 hours. This means that the service desk needs to be quite supportive of the IPS so that they can identify samples that or inspect samples that you send in and put together a signature really quickly. Must alert cybersecurity staff to concerted attempts to compromise systems. This means there must be a threshold environment or something like that. Must not reduce network throughput. Oh, that can be a really difficult one if you have, 10 gigabit links or something like that. That is an expensive IPS starting to take form. Must be able to block high and critical events. This means that there must be some sort of rating scale in those signatures. Hold on a second. My apologies. Must log attack traffic for 1 month. That's quite high level. Now, you notice these are all high level, but even at the high level, they're specific to certain targets. Like we've got 12 hours, 24 hours. We've got not reducing network throughput. They're high level, but they're not nebulous, right? So you can satisfy these with certain products. And it's important to get these correct at the start of the project because these requirements, and the business analyst will love these requirements. They love putting in a requirements traceability matrix so they can carry these requirements all the way through the project to keep the project on its rails. Because you think about a project that runs over a year, it might have 10 people involved in it that all have a different idea of what your project should do. But if you don't articulate it at the start this way, what the intent is and what the requirements are, then they don't have a clear picture. They'll make it up in their mind. It's just a natural thing to do. Oh, IPS, I know IPS. I'll throw it over here in front of the website because that's where most of the attacks occur. Maybe that's not what you're targeting. Maybe you have more information about where the attack's occurring. So it's important to get these requirements right up front. All right. Now, business benefit. There is a conundrum with cybersecurity that hits us all. If there's no incidents, then the perception is there's no real need to grow the security team because they're doing a good enough job and we're not having any incidents. If there's lots of incidents, then we need better security people, or maybe we need a new security team, or maybe we need to outsource it. There's a change that needs to occur. So this is the cybersecurity conundrum. Damned if you do, damned if you don't. And there's some sort of balance in there that we achieve to ensure that we're doing the right thing. Because if you are doing too much and you're spending too much and there's no incidents and nothing going on, then maybe you are putting too much into security controls. If there are lots of incidents and we're not making progress and the environment is constantly subjected to issues, then maybe there is something more that we need to do, or you need to expand the team or get different skills. So there is some truth in it, but it's a bit of a perception conundrum. What we need to show is business benefit. So we need to look at those incident reports not only from an internal perspective, but also the industry peers. So hopefully if you're a cybersecurity manager, you know some people in your competing organizations, those who are in organizations that are in the same industry but are clearly competing. Now, some people say, well, no, you don't give information to the enemy and you don't allow them to be more secure than you. If they falter and have a breach, then it's a commercial advantage to everyone else. And I'd say that's not really an ethical thing to do. You're not actually producing a product that is competitive. You're feeding off the downfall of others. And while you may come up with some really special ways of doing cybersecurity, it's important to share how other how organizations such as yourselves are being attacked, and share that with the industry peers, and very valuable for everyone. It's important to bolster yourselves in that area and give each other clues and hints into how to actually protect against it. And that is not only doing things for the common good, but it is keeping the industry as a whole safe and secure. Because if you find that someone in your industry or another organization, a competing organization, has a breach and you quickly go patch it up there, be sure that if they've had a breach that has been profitable to criminals, then those criminals will start targeting the industry itself, right? So if you're in the banking industry and there's a targeted attack on banking, and then that was very successful, they'll target other banks. So there is an element of being stronger together. I encourage you to be ethical and I guess holistic in your approach to security, not just for the organization, but for the broader industry. We're running out of time. Okay. Also, vendor reports. The one that comes to mind straight away is the DBIR. There's lots of antivirus vendors that have these as well, but the DBIR is really where you get the incidents from and the trends from. I think that's the best one, and I think it's in the reading list. And always ask, how does the business benefit? And then the final point there is likelihood. How plausible is the risk? If you are trying to address a risk that is not plausible, and it's the way you present it, then you will it will erode trust in your perception of risk. Okay, and that's the last thing we want for security professionals. I once, as a junior security professional, went to review a payroll system, and the payroll system was sitting right at a window of a high rise, right at the end, and it's facing out into a whole bunch of different high rises, right? And it seems absurd now, but I looked out at all the buildings that were outside the window in this city that I was in, and I thought, look, someone could just get a telescope and watch this person going through payroll all day and every day. But it's not a very plausible risk. There's not. It's possible, definitely possible, but not very plausible. And when I went back to my manager and I explained, I said, look, I really think this is a risk. I didn't overinflate it, but I certainly showed a concern about something that wasn't plausible, and it showed a lack of understanding of how the business operated. Now, there's certain ways you could defend that position and say, well, that it's quite sensitive information, someone with an intent that way, but it's not very plausible. It just basically isn't. So we always have to think about that. We're not trying to close every possible risk. We will turn ourselves inside out, never achieve what we need to achieve. We are looking for plausible risks. All right, so initiative phases, we have concept, we have design, and we have build and test. These are basic project management things. I don't really need to go through these too much, but in the concept, we get the requirements, we get a solution architecture, and hopefully we get a solution selection. That can sometimes happen a bit later. We then get design. We have a high-level design, how all the components fit together, very similar to the solution architecture. These are interchangeable sometimes. Then we get a low-level design, how the system's going to be configured. We then build. We may have it phased for different components, and then we test. Not just the functions, but user acceptance, and then also security testing to make sure people can't get into it that don't need to. Now, there's two main ways of deploying things these days, insourced and outsourced, right? Do you take internal resources and build the system in-house and keep the IP in-house, the intellectual property, or do you go to a tender process and get a vendor or an integrator to come in and implement it? Both have their pros and cons. Obviously, internal initiatives, you're relying on people you're paying already. They may already have jobs though, so it's difficult, and usually I would say an economy of favors to get things done, but you have a better chance of retaining IP. The tender process, you've got to ensure your requirements are very clear, very, very clear, not just clear for an inside individual, but clear for the uninitiated, which means you have to spend a lot of time in that concept phase to ensure that you get the right solution, because lots of workshops and things like that, because there are many, many ways for vendors to take certain statements in different ways, to interpret them differently. It's not as bad when it's an internal initiative because you're often speaking the same language, but for external vendors, it is difficult. You've got to think about quality over price. There will be very different excuse me, very different responses for a tender, and also you have to think about the keeping documentation in the tender itself, right? So that becomes a requirement as well, documenting how to use the system, how they put it together, all that kind of thing. And it's important if through all of this is that the people matter, right? If you do it internally, bet on those who are skilled enough to do the job, right? Bet on those guys. If you're doing it externally, find the vendor that has have the shining examples of well rounded professionals and those who are going to do the job well. Look for those key staff, whether it be internal or external, that will drive your project through. That is utmost important. It's going to be more about the people doing the initiative than the documentation or the scoping document or the tender response. Get to know the people, eyeball them, and get a sense, a confidence in their ability to do this stuff. All right, and that's it. We might take just 2 questions. I know we're 2 minutes over, but we'll take 2 questions, Margie. That's the discussion questions. That is the leaders and visionaries section of webinars. We will cover the cybersecurity management, bring it all together next week, so that we understand how to resource this beast that is cybersecurity that we're trying to perform in the organization. Do you have some questions for us, Margie?
Yep.
Yep.
So is it pointless setting up role-based access if no data classification policy is in place?
No, I don't think so. It's not just about data classification, it's also about privilege functions. So if you have an application that has the capability to wipe the entire data set, regardless of the classification of the data, then you may want to segregate that from a user class or a role that only needs to add one entry at a time. So role-based access control is still important if there's no information classification, because it's quite clear and easy to discern what is a privilege function or not as well. Cool.
Yep. So how much of a threat does personal use of the internet, including social media, at work pose to system security?
Well, it's another avenue for phishing attacks to occur. It also depends on the organization and the culture of the organization. It's getting more and more open, and I guess more difficult to have an argument to say, you know, social media is not okay at work. I don't actually. So there's 2 aspects to this. A lot of people say social media is no good because it's, you know, a productivity problem. I actually think a productivity problem is a management issue, not a technology issue. We can help management by providing information about how long people are spending on Facebook and things like that, and other social media, social networking sites. But from a security perspective, it's just another avenue into the organization. It's another way for people to export data and import malicious stuff. Keep letting the good stuff out and allowing the bad stuff in. You know, that's kind of what we're trying to stop, and it's just another avenue of doing that. So there are ways to secure that. You obviously want web filtering, you want application control. You can break the SSL, so you can seed every workstation with SSL certificates, so that you can decipher the SSL at the gateway, inspect it, and send it out. Also doing DLP and things like that as well. So there's ways to address the threat, but certainly because it's another avenue in and out of the organization, it is an additional risk just by the nature of it. We'll take one more, Margie, and then we'll wrap it up.
Yep. Do you have any examples of tools to audit file system permissions on file servers?
Tools to, that's yeah, I'm sure there is. That is a really good question for the forum. It is actually a really big problem, and that's something that isn't regularly fixed up. I think a lot of permissions kind of get out of control on file systems, and they're never actually reviewed or audited. I'm sure there's a Quest product for that, for doing a review of permissions, but I'll have to point you to it. But a really good question for the forum too. So I'll get back to you with that one. Thank you for the curly question. I like it. I think we'll call that a night. Sorry for going over for a little bit. I've really enjoyed this. The security architecture is a bit of a passion of mine. I've really enjoyed this particular webinar, and thank you for the questions. And we will see you all next week. Thank you, everyone.